right, ladies and gentlemen, thanks for coming. We're going to get started. Thank you so much for being here tonight. My name's Rob. I organize Idea the IPO. We've been holding events in Silicon Valley for many years. We hold events multiple times a week from San Jose to San Francisco. We always have a busy calendar of events. I'd like to highlight 2 events that are coming up. Next Wednesday, November 1st, how to prepare your startup for venture capital funding. That's going to be at Tech Code in Mountain View. Wednesday, November 8th, in this room, we have another venture capital panel, funding for IoT startups. So check out the details for those events and all of our events on our website, ideathipo.com. We were launched officially on February 1st, 2010. At that time, we had no members and no events on our calendar. At this stage, we have over 55,000 members among all our meetup groups in the Bay Area, and we've completed over 1,805 events. By any standard, by any measure, we're the most active, most prolific startup event organization in Silicon Valley, bar none. I appreciate that enthusiasm. Really, I'll take it. Our mission is to promote entrepreneurship, support entrepreneurs, build community, and provide value in the Silicon Valley startup ecosystem. To that end, we provide content that's practical, actionable, and relevant, stuff that you can actually use to succeed as entrepreneurs. We believe in building community because Silicon Valley is an aspirational ecosystem, and it draws people from all over the world to come here to do great things. I'd like to know who here is not originally from Silicon Valley? Who here was born and raised in Silicon Valley? Okay, well, it's kind of mixed tonight. Anyway, it's important for us to provide multiple channels for you to meet people, build relationships, and grow your network. With regard to value, it's important that we provide value at every one of our events. So we make sure that our events are affordable. If you cannot afford the cover charge for whatever reason, come see me and we can work something out. Most importantly, we want to make sure that we provide value at each and every one of our events for your time, which is your most valuable resource. I have to ask again, anyone here getting any younger? Probably not. So when you invest your valuable time to come to our events, we want to make sure that you maximize your ROI. We have many partners that help us do what we do: law firms, venture capital firms, angel investor groups, incubators, accelerators, colleges, universities, lots of other players in Silicon Valley. Tonight, we're grateful to the College of San Mateo and Small Business Development Center for hosting us at this beautiful venue. Is this a beautiful venue? Oh, great. Nice view, too, huh? So they are a great partner of ours. We've held many events here, and we look forward to many more. They're a great partner, and we are honored and privileged to be collaborating with them. I'd like to have Robert Schaffner from the College of San Mateo and the Small Business Development Center come up and say a few words. Let's hear it for Robert.
Thanks, Rob. I'm not sure if I'm supposed to be the straight man or if Rob is, but good evening and welcome to the College of San Mateo. I run the Small Business Development Center for the County of San Mateo, which is your resource to provide you services to help your business grow, thrive, expand, etc. We do that through providing one-on-one counseling for the business. It's free of charge. We're pretty effective at what we do. This year we have helped businesses attract just shy of $10 million in financing for their businesses, helped retain 70 jobs in the county, create about 45 new jobs, increase sales $2.5 million and counting. And last year throughout the state, we helped businesses obtain $967 million in financing for their business. So please visit my table at some point, and if you want to find out how we do that and how we might be able to help your business. Some other things we're doing right now, we just introduced an entrepreneurship certificate here at the College of San Mateo. We'll be kicking that off in January, so that's new. We're also just co-located down at Hero City with Draper University to move down into the ecosystem of entrepreneurship here in San Mateo, if you will. And so look forward to meeting you and helping your business grow and survive. Also, you will not be charged for parking this evening. So if you have that question in the back of your mind, am we going to be charged? I had all the parking waived for this evening. Thank you, panel, for coming out this night and supporting this event. And have a great evening.
So if by any chance you do happen to have a parking ticket on your windshield, just give it to Robert and he'll take care of it. We have a few other partners here tonight. I'd like to also have them come up and say a few words. Let's hear it for JK and Color Software.
Good evening, everyone. Thank you, Rob. Thank you for creating a nice platform to connect with entrepreneurs and learn from the expert panel. Thank you very much, Rob. So I'm JK. I am founder of a software development agency. We are an offshore development company. We are a 50-member team and 7-year-old company. So in last 7 years, we have our products have been reached to millions of users, and our clients have raised millions of dollars, and a few of our clients have successfully exited from their businesses. And one of our large client is now in a process. They are being acquired, close to acquisition by AT&T. So we have made a good mark in mobile business space. We wanted to do the same mark in the AI and ML space. We have a team working on the AI and ML. So if you have any software development needs in mobile and machine learning, so I will be glad to help you. Thank you.
Right, next up we have Michelle and Robotics for Good.
Hi, this is Michelle. I'm the founder of Robotics for Good. It's a community on AI messaging and chatbots. I also am a director of something called Robots Without Borders. We make AI that helps kids all around the world with education, medical assistance, and humanitarian aid. So contact me or see me over there if you're interested in AI and doing something for the world. Thanks.
So though our local mission is to help entrepreneurs here in Silicon Valley, our global mission is to democratize entrepreneurship and innovation all around the world. So to that end, we have a robust YouTube channel, youtube.com/idea-to-IPO. We have tons of videos. We've documented and archived many of our events, and this rich, valuable content is available on demand, anytime, anywhere, totally free of charge. Whether you're in San Mateo, Palo Alto, Maui, Moscow, or Timbuktu, anywhere where you have access to the internet. Our partner in this endeavor is Tim Jeggers of Jeggers Films, one of the top professional videographers in all of Silicon Valley. Let's hear it for Tim.
Thank you, Rob. Thank you, everybody. So I'm going to put the bell to the side. I'm doing the video tonight. I've been working with Rob for a while. I've covered events throughout the Bay Area for several years now. I also do About Us videos for companies, so if you want to tell your story about how you're awesome and what you're doing is awesome, I can help with that. And at the very least, I can give you a link to this video when it's done in a couple days, probably. So if you're interested in any of that, feel free to talk to me, shoot an email. Yeah, I'm going to pass it back and we'll get it started. Thank you.
All right, well, here's the schedule for the rest of the evening. We'll get right into our panel discussion. The panelists will have a spirited discussion until about 8 o'clock. Audience members, if you have a question for the panel, hold your questions. At 8 o'clock, we're going to set up a mic stand here, and we'll have half an hour of Q&A. Go right up to the mic stand, ask away, and we'll try and take in as many questions as possible. At 8:30 p.m., we'll end the formal program. Stick around for networking. You can talk to some of the panelists one-on-one. So at this point, I'd like to introduce our distinguished moderator. He is one of the top corporate attorneys in all of Silicon Valley. Really, he is an iconic figure in Silicon Valley. You'll see him at meetups, conferences, social events. He's everywhere. He's Roger Royce.
All right, thanks, Rob. Thank you, panel, and thank you, audience, for being here. By the way, make sure you get some sandwiches here. You'll notice we have vegetarian options now. You got vegetarian Subways, vegetarian burritos. I think the pizza is not vegetarian. But, you know, for the price you pay to get in here, I think the meal alone is worth it. My name is Roger Royce. I'm the founder of the Royce Law Firm. We're about 30 lawyers based in Menlo Park, Silicon Valley, with offices in San Francisco and 3 locations in Southern California. We do all technology startups and lately a bunch of ICOs, but that's not what we're going to talk about tonight. A little bit of fund formation and pretty much all areas of practice that any startup company would want, and a variety of industries, ag tech, fintech, health tech, and we apply a variety of different technologies, or our clients do, I should say, including AI, which we're going to talk about tonight. This is a great topic. I've moderated panels on this before. I like it because I always learn things. And in fact, normally I sit around, we have a big discussion with the panelists before the panel. We didn't get a chance to talk as much as I usually do, and I mentioned that to Rob, and he said, he says, I think I should just replace you with a robot. Being the gentle, good-natured, easygoing guy that he is. But ironically, that's sort of what we're going to talk about tonight. I got to thinking about it. Is this technology going to replace me as a lawyer, not so much as a moderator, maybe as both? Or is it going to replace doctors? Is there going to be a lot of displacement? And whenever there's displacement and disruption, we always have to ask, what are the opportunities? So to that end, let me ask you, how many of you in the audience are startup entrepreneurs? How many investors? Uh-oh. There she is. Service providers like myself? Okay, a couple of us. Did I miss any categories? Educators. We're in a college. I know we got one. Government people sometimes come out. So mostly entrepreneurs. So I gather what we're looking for, where the opportunities are, what's fundable, what's investable, what's hot, what's cool, what the next big thing is. And that's what our expert panel is going to tell us about. So what I will do is I'm going to introduce them by name, and then we're going to go into a panel, and I'm going to let them tell you directly a little bit more about who they are and how they come to this area. So on my immediate left, Ashish Agarwal, he is an investor in the space. Next to him, Istvan Janier from Nexstar Partners, Ho Nam from Altos Ventures, and finally Ed Fernandez down at the end of the table. So before I launch into grilling you with my questions, why don't we just go one by one and maybe talk a little bit about, again, how you come to the space, and we'll talk with you, Ashish.
It's a pleasure to be here. Thank you so much for everyone for coming. I work for a venture capital fund named Grecian Robotics. We are a $100 million fund, primarily investing in early stage companies, mostly Series A and Series B, writing between $2 to $10 million checks. And we invest primarily in hardware and robotics. And we also invest in software layers, so that means AI, ML, computer vision algorithms that complements that hardware.
Excuse me, can everyone hear in the back? Because we're competing. A little closer to the mic.
Okay, sorry. Just to reiterate, I work for a venture capital fund named Grecian Robotics. We are a $100 million fund, primarily investing in early stage companies in robotics and hardware. We are a global fund. We invest between $2 to $10 million checks. And we also invest in software, so that AI, ML, computer vision algorithms, that complements the hardware. And really looking forward to having the discussion and learning from everyone over here.
Okay, thank you. Istvan.
Thanks. Hi, my name is Istvan Janier. I'm with Nexstar Partners, a $100 million fund. We write checks up to about $7 million, and I specifically look at the frontier tech side of the house, anything enabled by machine learning, as well as smart robotics, media streaming, AR, VR, and so on. In terms of personal background, I come to this space having a PhD in machine learning from way back when. Then spent 5 years in academia doing machine learning research. After which I got an MBA at Carnegie Mellon, went to Google for a while, did a startup, and now I'm an investor. So looking forward to the discussion.
Hi, Ho Nam from Altos Ventures. We've been in Silicon Valley since 1996, so this is our 21st year, which is kind of crazy to think. So we got started right at the beginning of the internet bubble, investing in software, mobile internet companies. I think we've been pulled into AI basically by our entrepreneurs. And so before we made any AI investments, it's our existing portfolio companies that were starting to use machine learning for various use cases in security, in analyzing financial data, looking for fraud. And so what we're seeing, I think, is quite interesting. It's sort of like investing in internet companies in the 90s. Like every company is going to be an internet company. Every company is going to be an AI company. I think that is happening. And as a VC, my job is not to predict where the technology is going. I'm not a technologist, right? My job is to support entrepreneurs, back entrepreneurs, and when the technology is at a point where entrepreneurs could take that technology and run with it, then it's ready for VCs to play in it. And I think for a long time, it was the playground of IBM, Google, Amazon, the big boys. And now the technology and the platform that's available by Google and Amazon and others made available broadly is really going to open things up. And so it's going to be a very interesting next 10 years, I think.
Hi, Ed Fernandez. We started in the our venture capital journey 7 years ago with a small micro venture fund. That was a $10 million venture fund investing in different technology companies, both in Europe and here in the United States. We had a good exit last year, a company called Olapic out of New York that was sold for $130 million. We also had write-offs as well, like every good VC, I guess. We also are affiliated with Singularity University Ventures, so that's one way of having deal flow and understanding also how emerging technologies are going to impact the market moving forward. We work also with the Berkeley Center for Entrepreneurship and Technology as well, for the same reason. And lately, since 2015, we have been really looking into machine learning companies, not all of them, but those that have some sort of core technology behind machine learning, tools or enterprise tools that can be leveraged to build applications driven by data. And lately, we invested in a company out of Oregon called BigML, which is a machine learning as a service platform founded by Tom Dietrich. And really looking forward to the discussion and trying to help as much as we can to all of entrepreneurs trying to understand how it's best to finance a company in this space.
Okay, thank you, panel. So let's start off with a definitional issue because I want to make sure we're all talking about the same thing. I hear about AI and I also hear artificial intelligence. I hear about deep learning. I hear about machine learning. I'm sure there's other terms. So let's set up a few nets before we play tennis here and discuss what it is we're talking about. So I guess I'd like our panel, tell me what is AI and how does it differ from some of these other ideas that are out there in the market? And Ashish, I think I'm going to start with you because you and I chatted a little bit about this earlier, and I know you've got you've already had time to formulate a good pithy bumper sticker definition for me.
So I think from my perspective, I keep it very generic in terms of what is called AI. So the way I think about that is anything that is being done by human, when you try to program a machine to replicate that task, there is some sort of intelligence that is being built into the programming or into some type of logic that is being built in. I kind of consider that as an AI. And the reason I'm kind of keeping it very broad is because there are a lot of different use cases in which anything that is replicated by the machine that a human is doing, there is definitely some level of intelligence built into that. And of course, there are other things that AI can do that humans cannot, like fast processing of data and looking at insights. So I kind of keep it as generic as in that context.
Anyone want to add to that definition for me?
Sure. So I think that's a fair definition. You know, artificial intelligence is intelligence that's exhibited by a machine, right? And I think you asked what the difference was between some of the other terms that we're hearing frequently. I think we often hear the term machine learning and AI sort of as a phrase. And I think many people are not sure what the difference is. But AI really encompasses a lot of different areas and techniques, including machine learning being one of those sub-areas, expert systems, logic programming, cyber physical systems, knowledge representation, and it just goes on and on. And machine learning is very specifically the area of AI that deals with programs that improve with experience, right? So actually instead of explicitly programming the machine to do something, the machine learns how to do a task by giving an input set of data and the desired results. And so based on that, the computer figures out how to do that. And deep learning is actually a sub-area of machine learning and is actually a sub-area of neural networks, which is a sub-area of machine learning. And machine learning itself has many other sub-areas like support vector machines. Look, I'm not going to list all of them, but basically deep learning is the latest and greatest type of neural network that is able to do feature extractions at the very beginning and then traditional type of pattern matching at the end, all in one shot. You know, when we started doing neural networks, we really didn't have a lot of compute power to do all of that all in one shot. And so there was a lot of feature extraction, programming, and filters that were being applied to try to reduce the computational complexity, but it also reduced the effectiveness of the technique. And now, with the computing power that's available, all of that can be done with surprisingly effective results. So.
Yeah, that was actually a great tutorial. So when people talk about AI these days and machine learning, they're really talking about deep learning. And that's the breakthrough that really happened 5 years ago to do things like facial recognition, image recognition, language translations, or playing Go, playing chess, these kinds of things. And so that's really surprised a lot of people, but it's a very narrow field within broad AI. And so there are a lot of interesting things that are going to happen. But for the most part, when people talk about AI these days, they're talking about deep learning specifically. And that's the field that's really exploding right now. I think people talk about artificial intelligence and singularities coming, and there's sort of the artificial general intelligence that will someday be here, but I don't think it's going to go through deep learning. There's artificial narrow intelligence sort of applied, this technology applied at specific domains. And right now, as an investor, we're sort of looking at areas where, like particular verticals, particular use cases where deep learning can really have a big impact. And eventually, again, as that technology matures, gets better, you're going to see maybe more horizontal applications, more general intelligence. But I think that's a little bit a ways away. And the example I'd like to sort of talk about is, there was a company in the 70s, 80s called Wang Computers. Wang was a word processor. It's a hardware software company that just did word processing, very vertical. Like technology used to sort of address specific use cases. And what killed Wang, and they were worth like $8 billion, I think, at the peak, is not some entrepreneur who decided to do a better word processor, right? It was just killed because as a side thing, it was just general purpose computers, PCs. And there was just, word processing was one of many things that it did. They didn't try to kill Wang, but $8 billion of market cap wiped away. And so I think some interesting things are going to happen.
So little to add, maybe thinking on your companies or startups or your work as an entrepreneur, what I can add is that on top of what has been said, it's true that machine learning is actually one particular subset within the artificial intelligence field. Deep learning is even a smaller subset of technology. And in practice, you can think of this as another tool or another technology stack you can leverage for an application, for ultimately developing a solution for customers. So in a way, but it's not as different as other technologies that we have been through over the course of the years. For instance, I recall when we didn't have mobile phones with internet access back in the 90s, and then suddenly there was a revolution around the mobile, and companies needed to embrace very rapidly mobile solutions into their processes. So in a similar way, or the same process we are living with the cloud is happening with machine learning, which is an enabler of AI, and AI in the future. Now, when you look into your own company and when you are building, you may want to look at this as another technology block you are leveraging for something else. And that something else is the important thing, which is solving a problem for the customer. The good news is that today we can say that the tools are maturing very fast. So no longer you need to be really a data scientist in order to leverage machine learning. There are tools, platforms that you can off the shelf take the algorithms, run your own models, and very quickly come with predictions, and that could be essentially one of the components of your application or your solution. It may be completely transparent for your customer, but you are benefiting from machine learning in the inside, and that's what is driving optimization and efficiency, and this is what really the machine learning wave we are living right now from a venture capital perspective. This is what is happening, that we are investing and seeing companies be more efficient in things they were doing traditionally in the same way, but now with machine learning they can optimize the process, reduce costs, and be more competitive in the marketplace.
Yeah, absolutely. You know, on that point, let's drill down on some of the applications, but it kind of reminds me of some that I've seen lately. So, you know, as I mentioned, we do a lot around agriculture and agriculture tech, and one of the companies in our network recently exited. They had a machine, it's a robotics, but it used AI technology, and it rolled down the field, and it would spot invasive weeds, and it would figure out if it was a weed or if it was a plant. Use these down in Salinas, for example. And if it determined that it was a weed, it would spray a little bit of pesticide at it, just a little bit, just enough to kill the weed, and then keep rolling until it found the next weed. It would do this at super high speeds, okay? Very, very, you know, there's a great example of a use of an AI to make a process way more efficient. I talked to a farmer in Texas a couple of months ago who said this particular machine causes him, you know, has saved him, he uses 5% of the pesticides that he used to because of this AI technology. It was just sold. So that's one good example. I've seen several others, but maybe you guys can tell me some other examples of use cases where AI is being used to make, I guess, machines more efficient and businesses more profitable. Anybody?
I have several, so just to provide one, and also to the point I was trying to make, that sometimes you don't need to be an expert, or the technology is already mature enough, you don't need to be an expert any longer in order to leverage machine learning. Simple things like, this is a big telco customer, traditional operator selling mobile services. They simply run some specific machine learning algorithms in order to cluster, to make a better segmentation of the customer base. So based on historical data, looking into patterns or specifics around those customers and their behaviors in terms of using mobile services. There is an array, they have a ton of information about what we users do with our phones, and just running simple models, they were able to find those specific associations between their customers that were more inclined to buy another service. I recall this because I remember these guys working for, I think it was 3 weeks and a half, running different models, using just a simple platform in order, you know, like really import the data, and cleaning the data, preparing the data was actually the majority of their time. Then running the models was like literally 3 or 4 days. And when they applied that into their marketing offerings of the carrier, when that was going to the market, they saved $3.5 million out of nowhere. Suddenly they were more efficient, and they reduced their marketing spend in $3.5 million in just one country. So this gives you a sense of how powerful these tools can be in practical ways.
Yeah, data, I can see how that would be a good application.
So simple example in security, one of our companies called White Hat Security, that they look for vulnerabilities in web applications, websites. And so they're scanning through every single line of code on the web page and identifying vulnerabilities. You don't want to miss anything, so it flags a bunch of things. And so we call them false positives. It's like, oh, this could be a problem, this could be a problem. And a human being actually has to look at the potential problems and determine, okay, no, this is not a problem. This actually deserves further investigation and so on. So this is a company that's been doing this over 10 years, and they've collected enough data now of validated real vulnerabilities that's human validated, and they're feeding that into the machine learning so that it can get faster and you need less human intervention and the machine just starts to improve over time. But again, in order to make this machine learning work well, you have to collect a reasonable amount of data. And so we're just seeing these kinds of use cases come up more and more. Now that the technology is available, it's kind of free. I mean, it's pretty cheap. And people are just experimenting with it. It's like, hey, we have this data, let's feed it, let's see if it works. Is it, producing validated, results? And like in that particular company's case, in the first, few weeks, they were able to get results that were surprisingly good. And so, again, this is the kind of thing that we're seeing with companies that were not AI companies in the beginning, but this technology is now widely available, and people are starting to experiment with it.
So, the way I look at the recent enthusiasm about machine learning is really it's starting with deep learning, as was mentioned before. And so what types of tasks is deep learning good at? It turns out that the canonical example here is image recognition. And in a broader sense, just sensing the world. So the initial successes actually came in the ImageNet competition, where I think in 2014, the winning team had an accuracy, not 2014, 2009, the winning team had an accuracy of 75%, and 3 years later, with deep learning approaches, the winning entry was actually superhuman level, over 95%. So image recognition was one good example. The other one is speech recognition. So you probably noticed that you're talking to your phone now a lot more. A lot of people are dictating messages as opposed to typing them. That's due to the deep learning techniques as well. So in general, deep learning is actually good at sensing the world. And then the interesting thing is that then you can, once you can label things and understand objects, then you can then step back into more traditional machine learning techniques like logic and expert systems to then deal in the symbolic world. So if you sort of step forward the image recognition use case, then you can then analyze the scenery that an autonomous car is looking at. This is a tree, this is a road, this is a lane divider, this is a building, and so on and so forth. And then basically understand scenery as well. So the next steps would be not just recognizing objects, something is here, but what we don't have figured out yet, but would be the next application there. What is the intent that a human is going to do, right? So if a human is standing on a curb, are they going to step off? Were they walking in a certain direction? Are they walking up to a bus stop, or are they going to continue walking in the same direction? So you can actually extrapolate from there the use cases of machine learning. And then extrapolating on the other side, in speech recognition, my favorite example, from just simply recognizing what you're saying and transcribing it, really understanding what you're saying. So natural language understanding is a hot area right now, and a lot of people are working on it. One of my favorite companies was Maluba, that got acquired by Microsoft, that was achieving very nice results. And the speech recognition accuracy is actually improving just by sort of incrementally adding to the knowledge base that really understands what you're saying. So I'll stop there.
Yeah, it really is. I mean,
and
Alexa is amazing now, isn't it?
Yeah, and that speech recognition, right? That was the high hurdle. But now that we're there, the machine is so fast, right? And now we're talking about real-time translations. Like, no problem, like any language to any language.
Yep.
You know, this sounds like science fiction, but this is happening. So, you know, I heard a story about Google, I think a couple of days ago, where they had a big team doing Google Translate, and they let the machine learning team just sort of play around with the stuff, right? And in a fairly short time period, a small team applying deep learning into this translation area, they were achieving stunning results. They were achieving results better than what they thought the existing team would achieve 5 years from now. So they just disbanded that whole team, and they turned all of the translations over to the deep learning team. So that's the kind of stuff that's happening now.
At the same time, kind of looking at, I think, general intelligence that we believe can replicate whatever human is doing, I think is still far away. A lot of these use cases are very, very vertical specific. So a lot of the stuff that we are seeing, at least, they are applied to a specific vertical. So because of the constraints that are generally available, that's why you start seeing a lot of these companies that are currently building vertical intelligence. Because building a general intelligence that can replicate all of these things is is extremely hard, and I believe that is still many years away on that for us to solve that problem. Specifically, even for two use cases that comes to mind. One is within warehouses, like Amazon acquired a company called Kiva Robotics back in 2012, and that kind of created a big void in the market. What Kiva Robotics was doing was, within a warehouse, imagine like as e-commerce is growing, 50% of the time is spent by a worker within a warehouse to actually look up the order, to basically walk to the particular place where the object has been stored, pick that object, bring it to the packing station, and then basically pack that order. So what Kiva Robot was doing was they were basically moving entire pallets of goods automatically to each worker, depending on which worker was looking at and packing which order. So there are a lot of innovations that are currently going on, which are focused on doing picking and packing versus building a lot of AI into solving warehouse automation of robots, where people are building either better pick and pack type of robots versus kind of building a complete warehouse as a solution where you are either reducing human labor cost. And that has a direct example of improving cost for these retailers, because Amazon is really pushing down a lot of pressure on a lot of these retailers to become more and more profitable on that side. A second example would be kind of in terms of looking at self-driving cars. Specifically, I think what my colleague mentioned over here on the panel, I think because of the problem being solved on the sensing side as well as on the perception side, there is still a lot of problem that is where people have to kind of understand. Like, imagine a car traveling at a speed of 70 miles per hour. Now, this car has not only to get all the inputs from various sensors, but it also has to forecast like at least 90 frames ahead, like at 30 frames per second. They have to know at least in the next 3 seconds what can happen in the car. And then when you think about like how this car is driving next to other cars, suddenly the amount of data that is required to compute becomes so huge that even current GPUs cannot handle and process that at the edge. And that's why this is what people call like a safety use case within the self-driving car realm, where it is which is going to be a big problem unless we hit a level 4 or level 5 autonomy, because unless you can like stop the car and you can be sure about predicting that 90 frames ahead what's going to happen, it's going to be very hard. Like if you're traveling at much slower speeds, it's a lot more easier. That's why you start seeing more and more of these delivery robots kind of trying to do the automated delivery on that side. But that's just another example of like how safety use case kind of in some of these areas is going to play a lot more. Even when the technology catches up, it's going to be a little bit difficult for us to become more comfortable with seeing more and more machines around us.
Interesting. So let me take a little bit of a step back here from the use cases and ask you about more the AI companies. I gather the entrepreneurs here, how many are working in AI? Okay, so most of these people are in the space, and I know what they're wondering. They want to know what you think is a successful AI company. Not so much if they've targeted the right vertical, but what does it take to be a fundable, successful AI tech company for you? What do you look for when you look at AI?
So I can jump in with that. So I think that, first of all, I cringe a little bit when someone says, you know, an AI company, because I think AI is a technique, not sort of a problem that's being solved. It's, you know, saying something is a cloud company, right? So well, what do you do in the cloud? So AI is really a technique, and so then the question is, how do you make an investment thesis around a technique that's being used? How is that a differentiator that's going to, like, you know, a sustainable differentiator? Is AI really a sustainable differentiator for the startup? And turns out that there are a few ways that you can figure that out if that's the case. Turns out that many of the algorithms are becoming commoditized very quickly, right? Even in deep learning, which is the hottest, greatest thing right now, you can download any of a number of frameworks and you can get started. Models are being published all the time. Proprietary algorithms are really rare. You can kind of figure out how things are being done. So algorithms are not really a sustainable differentiation. Turns out that data is, right? If you have proprietary data, or you can develop a data flywheel in which you can acquire data, and as the system works, it performs better, which then generates more data. You can acquire a lot of proprietary data and run faster than your competition. So I really look at the data, and then the third one is the team, which is a general VC checkbox that we look to check. But it turns out that machine learning is hard, and you really need an expert team. Even though, you know, I say that models are easily you know, downloaded, but you still have to really know how to make them work. And one example I point to is back to the ImageNet example, where in recent years, I think the last time I looked was 2015, the best team was Superhuman, but the worst team was 85%, you know, using deep learning. So it really does make a difference who's building the tools.
Yeah, there's still a big shortage of AI talent, and it's mostly people who understand the technology enough to understand where it applies, where it doesn't. But I think I want to echo the comments on you know, the big companies like Facebook, Google, they have so much data, right? And so if you think you have a better algorithm to do ad serving, it's like, well, that's just not gonna work. So what are the areas where, you know, like the White Hat Security example, where they have a unique data set over 10 years, human verified data? That's kind of interesting. We were talking to another one of our companies where they're in the e-commerce business. They process about $5 billion of transactions. So they have an interesting amount of data. And what he was saying is interesting, because he was a CTO at one of our other portfolio companies that did pricing optimizations for big retailers. So we had Walmart as a customer, we had Target as a customer. They were paying us $50, $100 million to get access to this technology. You know, even though that company had way more data that they were processing, all this POS data, the level of I guess the value they could add at this little company, Coupang, that had $5 billion of data versus this other company that had $200 billion of data, it was just not even close. Because as a small company, you're able to get the data, and then you're able to iterate, like he talked about the flywheel effect. So they could put out an experiment, a pricing change or whatever it is, and then within the same day, they'll get the data back, and then they will iterate and then iterate. Whereas if you are a SaaS company in the prior company called Demantech, okay, you know, we sell to Walmart and they pay us a lot of money and they use our software, but it's like a black box. I mean, they're using our software, but we are not getting that data back on a daily basis and iterating. So we look for data and then the ability to close the loop very quickly. And if a company has that, you know, maybe they have a shot against the Googles of the world. But if you're looking for some competitive advantage because you have really amazing talent and you have better algorithms, that's going to be tough to compete against the big guys.
Yeah, I totally agree with what you said, and I believe that what we look is, in particular, in those companies that are pitching AI as one of the technology elements, first of all, is already probably a red flag for all of us because there is too much hype around the term itself. So whenever someone says, I have an AI company, there is a ton of questions that immediately come after in order to clarify exactly what it means. And it's no different than using other technology elements like cloud, as we said, or others, in order to provide some sort of ultimate benefit for the end customer. So while we will look into a company that has machine learning or AI as one of the technology elements is to understand clearly what is the optimization or value proposition that they are bringing to the market by using that technology. Questions like what models are you using, how are you updating those models, coming back to the flywheel effect, what is the data residing, how do you generate the data, how do you learn from the data, and ultimately you want to compare an existing process, typically an enterprise process that is working one way without machine learning or AI, and what will be that process after you apply machine learning or AI. And then depending on the efficiencies, and again, the efficiencies means cost reduction or improvement in whatever ultimate application you are building, that will be the company fundable or investable. Typically, we look like short-term horizon, and then we look also like long-term. Long-term, how can that competitive advantage be maintained? So two things is, if you apply machine learning today and whatever the reason in that market, in that vertical, there is not still players doing that, you have a competitive advantage, you can go fast to the market, you can benefit from that, there is value to be created. That's okay. Now, if that is happening in the short term, how much in the time can that competitive advantage be maintained? That's the second question, in order to understand what could be the return on the investment in the long run.
Just one more thing to add over there. I think we always kind of like trying to ask, okay, what is the solution that you're building? Because AI is like a tool, and then when you're applying that tool, like, okay, what problem are you solving? What value add do you have? What proprietary data set that you have access to that is going to become better and better over time as you get access to more data? Or is it like some type of other data sets that you're combining in a unique way through which you are able to kind of like get a lot of data sets? For example, in agriculture, a lot of these people are using satellite data combined with drone data and then combine that with mapping data to kind of understand and build a very high resolution maps to understand and predict, and then applying predictive maintenance to figure out how the crop is going to behave depending on the weather conditions. And I think based on that, that access to that type of information where you're taking this to solve a particular problem in a way that has not been done before, I think that definitely makes you very, very valuable. The problem is like kind of whenever if you're trying to build a horizontal platform, you kind of like run into the problems that larger companies are solving and going after, like Google, Facebook, Amazon. Whenever these companies do their large developer events, every time there are like 5 or 10 startups that basically get wiped out, primarily because they were just building a product which ended up becoming like a free feature in the next version of their product release for these larger companies. So it's actually a very valid question to understand. If you're building a very vertical solution like in healthcare, like in agriculture, those are not the areas where these companies are ever going to go after, at least.
That's really interesting. I wouldn't have thought that the real benefit would be in the data and not in the algorithms or the technology. I would have thought it's the other way around, but I think what I'm hearing is that the technology is a tool, and maybe you got a better mousetrap, maybe not, but it's what you're doing with it. Now, can I ask you, are the companies you've seen, are they data companies or are they something else? Because I keep hearing data keep coming up and up again, you know, as they're using their tool. For example, that health tech company you just mentioned, it's gathering data on a lot of patients, as it's doing this. Is that the value that these companies have in the data, or is it actually in the customer relationship and the tech and the tools and the revenue? What's more valuable?
See, that's a good question. So the data is the byproduct. So if you have a really valuable company, right, you have these great interactions with customers. You have customers, first of all, right? And so because you're doing transactions and you have customers, you're in business. You have to be in business. So if you're in business and it happens to be a successful business, guess what? You have a history of a lot of data. You get a lot of transactional data, a lot of whatever. And then that data then becomes valuable. It's not the data per se that makes the business valuable. Your job, number one, as an entrepreneur, is to create a valuable business, which is, okay, like what need does the customer have? Who is your customer? And then if you solve that need for the customer, then you have the opportunity to start collecting a lot of data. And then that starts to snowball, right? Then you can start to apply machine learning and all. But the job number one is like solve a problem. Add value, create value, and charge something for it, make money. And then if you start to make money, then you're not going to go out of business. And you're not going to go out of business for a long time, and you deal with lots and lots of customers. More customers, the better. Then more data you collect, right? You get smarter.
So you need data for machine learning, right? Machine learning is the fuel. Data is the fuel for machine learning. So, not having data and doing machine learning makes no sense whatsoever. And most of the time, you need lots of data to have interesting results in machine learning. And let me just throw one observation out there, which is that a lot of companies come to me saying, we're using machine learning to do X, Y, and I cringe at that pitch because why are you saying that? You're saying that because you think you're going to get brownie points for saying machine learning, when in fact that's an alarm for me, because it turns out that machine learning is actually is not 100% accurate, right? It's machine learning. I say machine learning, but really deep learning is what we mean here. It's mimicking how the human brain works, and just like the human brain, deep learning makes mistakes. So then, if you're using deep learning, how are you going to deal with your mistakes? Was it really necessary to use deep learning in the first place? It turns out that if there is an algorithmic solution, that's what you should be using. It's aside from bugs, of course, it should be 100% accurate. So that's actually one of my other questions is machine learning really necessary, or are you just saying that because you think you'll score points with an investor? And some startups will actually use it just so they can justify saying that they are using it, which is not at all helpful. And then another aspect is you need to use machine learning in the main line of business, right? If you're using it, to build some personalization, sure, it's going to help, it's going to lift your business, but you're not really a machine learning company. But yes, so data is definitely needed, and I think it's sort of it's not even to think. So it's sort of the opposite, right? Do you need data to do machine learning? Well, it's not like that. It's if you have data, then you might want to think about using machine learning to extract patterns and information, and if that's the best way to go about it.
I beg to differ. I don't think you need data for everything, because, and I'll support that with an example, because in certain cases, like if you have a predefined, really good understanding of the rule set, then in that case, you don't really need any type of data. An example of that is like when DeepMind came up with AlphaGo, then for AlphaGo, they had basically a lot of like 100,000 plus games, and that data was kind of like fed into the machine so that they were eventually was able to beat the best alpha player in Korea. And what happened like a couple of weeks ago was that Alpha Zero, which is the new program, this new particular program was based on reinforcement learning. What that means is that you basically had a loss function where the main thing was like, hey, eventually, after every move is being made, the function is basically describing what is my chances of losing or winning based on this particular move. And then automatically, without using any particular data, this algorithm was able to teach themselves on how to play Go. And this version of Alpha Zero, basically not only was able to beat every single other version of deep learning players, including AlphaGo. And when you think about this particular machine, this algorithm was running on using only four TPUs from Google, and within 3 days it was able to do that. So, of course, I mean, the reason it was able to do that was because the only human logic that was programmed was the set of rules, which was predefined because it is a board game. But then when you're talking about problems like, for example, how a car should behave in a real-world environment, we don't know a lot of these variables. So we cannot give an input of like what is a well-defined set of rules that this particular car should follow. So in that case, that's why we need a lot of data to train them. But the problem with data is that the data, whenever there is a data, whoever is labeling the data, there are inherent biases that are coming into that. And it's just kind of like whenever, and the reason the biases are coming into this data set is because the way the data is being collected, people don't think about some of these ways because even the data is being collected by a human. So there are inherent biases into the data that kind of goes into the algorithms. So, and which is kind of turning out into a big, big problem as you start thinking about like these algorithms kind of like starting to differentiate. For example, in some of the earlier versions of image recognition algorithms, when they started feeding kind of images of like dark people, like brown people or black people, it started saying them that they are chimpanzees. And this is not because the algorithm is bad, it's just because the data that was being given, they did not have given enough data set to help the algorithm understand the different versions of skin on that side.
You know, that AlphaZero is a very interesting example. Actually, that goes against what we were just saying, that data is so important, because less data actually won in that case. Because it was kind of remarkable, because AlphaGo learned from all these past matches, right? And so it played like a human, and it beat the best human. But AlphaZero played itself. It learned by playing itself. And so when AlphaZero started to play other humans, it was just blowing people away. And what the comments were is like, this is a player who's alien. Like they've never seen anything like it before, because it did not learn from the human matches. It just learned on its own. So it's quite an interesting case.
Yeah, it's an interesting case, but it's also, AlphaZero is also not a startup or a company, right? So, sure. Game playing is a very niche application of machine learning, and sure, self-playing does provide remarkable results, but I think most startups are going to want to deal in the real world, and in that case, you might want some data.
Okay. Well, we're at the top of the hour, so I think I am going to turn it over to Rob so that he can open it up to a few questions from our audience. All right.
Let's hear it for our panel. So we have about a half hour of Q&A. If you have a question, just come on up to the microphone, ask away. We'd like to answer as many questions as possible. Come on up.
This is related to data collection, but as someone with an idea, when someone with an idea want to explore and extract the insights from the data, not necessarily they'll have the that large volume of data that is needed for ML or deep learning to explore, right? But how much importance do you give if there is a synthetic data? They create the data, play with it. Definitely it may not be matching to the real-time data, but it is like 80% accurate. Like if I want to create certain synthetic data, so what value does that play in your idea evaluation?
Let's repeat the question for the audience.
So let me try to see if I even understand the question. So are you saying that what if you don't have data and you generate synthetic data to jumpstart the learning process?
Yeah, and synthetic data will always be not accurate to the real data, and there will be certain gaps and certain assumptions. So
yeah,
how does
that's a valid approach. You sometimes need to seed your data set, but then ideally you want to then supplement it with real data, right? So I think it depends on what stage of an investor you are talking to. If it's a idea stage investor, you have to convince them that this is going to work. Later stage investors are going to want you to apply that and bring in real data. Yeah, I don't know that there is a one good answer to your question. You have to start where you can, right?
Okay. So I think just to add on to what my colleague Estoin is saying, so I think there are alternate ways in which you can start thinking about. One is try to see if there is public data sources. A lot of universities have a lot of public data sources available for research, and you can reach out to people to kind of like get that data set. Other thing you can do is there are companies that are actually generating these type of data sets for whether it's voice data sets or different type of data sets for you, and you can buy those data sets from them. Like for example, there's a company called Define Crowd, which can generate NLP data sets for a lot of larger companies, like including Sony. So you can try to reach out to them, and they are trying to basically generate data. So there are ways in which you can try to get proxy data, because synthetic data is can be good, but I think you should always try to get the real data set as much as possible. I mean, synthetic data set is, of course, can be used for complementing your existing data sets in that context.
Are you able to say what kind of problem you're going after?
Basically, I was just exploring, so it's more like to understand about, if I want a complete dump of the traffic movements on a road path or curb, or related to self-driving car, just explore.
I think the city of New York makes their data available. So
Okay.
Yeah,
Okay.
so
Yeah.
if that's
Thank
what you're
you.
looking for.
And one continuation, maybe I can take it later, but with respect to efficiency, I think one of you mentioned, right? So when someone is exploring and playing with it, may not be able to give the efficiency because it will be more on AWS or other sources, but the comparative ranking with a GPU or a NVIDIA kind of cards can shoot up the efficiency, right? So should that be considered when discussing the ideas or anything? Should that be tested? I mean, just I'm not sure.
But maybe one way you can look at this in terms of putting value on data, it depends on, let me rephrase this. If you plan to apply machine learning to the data set, to the ultimate data set you are working with or generating or working with, probably one of the major problems everybody will be facing is the feature engineering for the model in order to make it more efficient, more accurate, more whatever, and ultimately the value will come because of that. And feature engineering is directly associated to the quality of the data, the variables that you have, the variables that you can produce. So that's one way to really screen out what is the value of that data. So if you are able to generate new features, for example, that may be very relevant for the model, that will generate a huge improvement on accuracy, that's one way of setting up the value chain and how you can look into your data set and put a value on top of it. So whatever you are running or the kind of ETL transformation you are doing are capable of really creating very good features for the model that has a ton of value.
Okay, thank you.
Good evening, gentlemen. I have a couple of questions for you. First is, do you think that online learning programs sponsored by big tech companies around things like deep learning are going to be effective in trying to close the skill gap?
I'm sorry, close what gap?
The skill gap.
Oh, the skill gap. Okay,
For
online
AI.
learning. And these are, I gather, you're referring to AI-powered systems.
I'm talking about online learning around things like deep learning sponsored by Google and other companies. Right? They're desperate to find people who can do this work. But these courses are, they're pretty short. Several weeks or maybe 6 weeks at most.
I think, we invested in, we have an investment in an online learning company. So we're believers in it, but there are limitations to what online learning can do. So online learning is out there, And so for the motivated person, the content is out there for people to learn, right? And then there's MOOCs and all that stuff too. You could take online classes. But for somebody who is not extraordinarily self-motivated to like go through it, it's really hard to sort of just to learn the necessary skills by yourself. But if you are motivated, I see people like, you know, doing remarkable things. You could be in Africa, you could be in China, you could be anywhere, and you could become, because all the content is out there. But you know, where schools come in is sort of like, it just gets you in the classroom, forces you to do the work, or somebody's actually watching over you or answering your questions. So that hand holding through the process makes a big difference. So there's a company called, oh God, forget, Springboard. So anybody could go to Springboard, you could take a class. The difference between their online learning classes for machine learning and other classes is that they actually then match you up with a mentor. And so you then work with somebody who has a job that you want to hope to get after you complete this course. And they charge you a lot of money for that because it costs money. But you know, these are people who work at places like Dropbox and Airbnb and Google and so on. They sort of want to mentor and give back. And so, you know, those kinds of options are pretty good. And they went down that mentorship route because the pure online learning that they started with was not getting enough course completions and not leading to enough proficiency.
Yeah, I think it matters more who is doing the learning rather than who is doing the teaching. But I can tell you that, you know, tell you my story. So I started coding when I was 11, and I was a whiz by the time I was 12, right? Of course, and I knew everything, except it turns out when I then entered college and had to go through all the theoretical courses, then I figured out that no, I didn't know a lot, right? So didn't know anything about formal language theory, didn't know about computational complexity, and I couldn't figure out why my sorting algorithm that I so cleverly devised wouldn't run anymore once my data size started getting larger, and I didn't know that I actually just reinvented insertion sort. And you know, the algorithms course gave me a whole different tool set. And so I think the same is true here. You know, you could take an online learning course and learn about the basics of deep learning or some other machine learning you know, tools, and then go through the tutorials and think that you're able to do deep learning. But once you actually have to solve a real world problem, then you might really run into some insurmountable challenges, and what you're going to be missing is probably the foundations of computing, and that's just hard to, because you probably don't know that you should be looking for that knowledge base, and so how are you going to get that?
So if you're a motivated autodidact, you can save yourself 20 grand, you know, by teaching yourself instead of going to code school.
I'm sorry.
Well, if you were to take an AI course here in San Francisco, it would cost you 20 grand at a code school. But you could, if you're motivated, you could go online and do it yourself, and it would cost you, maybe $400.
You can definitely, you know, get to a certain level, but you know, you definitely, I think you need to look at formal computer science curricula and see what's in there and why that's important. And it's just sort of hard to get all of that from a pool model. I think, you know, some of the things are really difficult. That's really, you just need to be forced to go through all of that difficult learning to get the full exposure.
Sure, you have to have a foundation to build a house, right?
Yes.
So the other question I have for you is getting to that last 5%, right? That's probably going to be harder than getting to the 95% of accuracy, right? That last 5%, the last mile, it's always the biggest problem. Could you use multiple data sets? So let's say you run a problem through an AI. It's got 95% accuracy. Well, you run it through a second AI with a slightly different data set that overlaps. You think that you could do that 3 or 4 times and get a couple percent?
So that's getting a bit too technical. I think this is an AI startup panel. We can talk after.
All right, thanks so much.
Sure.
Hello. So I had a question from kind of a different angle, which has to do more with the investment side. And I was curious how you see AI changing the decisions that are being made about what companies are being invested in, and if you see maybe in your companies or in other folks' companies, ML and AI being used for early detection for deal flow. Thanks.
Okay, so you may recall I mentioned that we are investors in a company called BigML. They have a machine learning as a service platform, but as a spin-off of the company, there is another company, another startup that is using this platform in order to predict or score startups for investment purposes, to your point. Long story short, we are not still to the point that the machine will tell us where the right bets are going to be, but certainly at the with the state-of-the-art technology today, we can squeeze the process in terms of coming up with a good scoring of the companies. So ultimately, for investment purposes, we need to build a risk profile of a company. So it's all about analyzing the company and understanding what are the risks, and as investors, making a bet ultimately. But then, during the screening or due diligence process, you need to understand the status of the company. Many startups have already much of their information available, even if not all of it, in a way that you can very quickly run these machine learning models, make comparisons with existing historical data from other startups, look into other similar companies, and come up with a scoreability of the company that will, in my experience, reduce the time of the analyst between 3 to 6 hours. So let's say that you get, like in our case, we get like a dozen of pitches per day. So in a week, typically, we go about looking into 100, 150 pitches, but we have only one analyst at one and a half. So this person can now run very quickly these models, get a score of the company, and say, okay, I am not going to waste any time on these ones, and I'm going to concentrate on those ones because have a better score. And then go on with the traditional process. We are at that stage today. And actually, when we receive any pitch, the first thing we do is to enter the name of the company and get the score. And the score is based on data from Crunchbase, Capital IQ, LinkedIn, the patent office, all those kind of things that essentially build up some sort of comparison with historical data to predict how the company is going to do well or not. This company, by the way, is called Pre-Series, so you can sign up on the web and see for yourself as well.
Great, thank you.
Hello, my name is Alan. I'm working on applying machine learning to recruitment process. And I have 2 technical questions. I'm not sure if you can answer me on that. Do you see that edge computing or like machine learning can be applied on the edge, and can you implement that in hardware to protect your algorithm? Did you see like some hardware edge implementation of that?
Great question.
That's the first question.
Great question.
So yes, you can do machine learning on the edge. So machine learning has 2 phases. One is the training, and one is the testing phase, right? When you're actually executing. So you could, the currently prevailing model is to train in the cloud and execute on the edge. And so even, you can now have algorithms that can do object recognition on your photographs, even on a fast smartphone. And there are many companies that are proposing hardware implementations to go into the chips, special purpose, ASICs basically go into hearing aids and various other devices. I think that when you're saying, can you protect your algorithm by putting into a hardware, I'm not sure why it would make it protectable that it's in hardware. In fact, I would say it's the opposite. If you put it into hardware, then you freeze it in time, and the software players can leapfrog you with a continually evolving algorithm.
Okay. Second question is, what is the best way after you train that network, what is the best way to transport and store that data? I mean, once we learn from our mistakes, and we call this experience, how does this translate into data sets? How do you store that data, and how do you transport it? If you need to shut down your network on Google Cloud and move it to Microsoft Azure, how do you transport the data? Maybe it's a technical question. I'm fine without an answer if you don't have an answer.
It is a technical question, but I think those clouds have very fast connections between them. You can move data very quickly.
So what is the format of data? Is it like files? Is it like, what is the format of, once you get the training and once you get the Alpha 0 machine knowing all the moves, how do you store that?
Yeah, you need to have a technical co-founder. That's the...
I'm working on that.
One thing you may want to consider, there is a very good paper by Google about federated machine learning.
Okay.
This is tackling this problem because think, for instance, mobile devices and personal information. Because of privacy issues, moving the data, as you mentioned, is sometimes even not possible. So how do you make the machine learn if you have these two different stages of the model? That one phase is training, and you need the data available even from the edge, from mobile devices in this case, stored somewhere in the cloud so that you can train the model. So it's actually in some cases not possible. So I recommend that you go over this paper in particular because they have already been working on machine learning in the edge in a way that those machine learning models are actually running in the device. So instead of having one single model, like, let me rephrase this. Instead of having one single big model trying to learn and looking for ways to move the data around, you are having different machine learning models at the edge, working at the edge, that will learn by themselves, and you combine the learnings. So rather than transferring the data, which is not possible maybe in some cases, you transfer the learning. And this is proving to work well so that you get the same or similar levels of accuracy in those models by doing this. There is another company called, it's a startup, a very young startup that is working on this. It's called Accuration. I can send you the details later on if you are interested. Yes. They are exactly working on that. They have already a prototype which is working with they showed me the other day, a pile of Raspberry Pis that are working in the edge, and they are running those machine learning models and then combining, transferring the learning, and they were able to match the accuracy of the Google setup. And now they are working with Kinects to make the next demonstration. So that gives you a sense of how the trend is going.
Okay, thank you. Thank you.
Hi, everyone. So my company was a machine learning company, got acquired this year. We started in 2009, 2010, and the world has completely changed in the last 8 years. When we were first going out on our road shows, we were asking people, are you familiar with machine learning at Strata and the other big road shows? It's very different today, of course. We're sitting in front of you guys, and you're talking about support vector machines and reinforcement learning. It's amazing to hear that. My question is, from an investment point of view, what's different today when you have co-founders pitching to you than maybe in 2009 or 2008, besides the financial bet down, which had a big effect on things? But from 7, 8 years ago, is it any different today as far as what you're looking for?
Oh, okay. Okay. This is my personal experience, and it may be applicable, or you may agree or may not. I think the difference now is because some years, almost a decade has passed since I started my personal journey in venture capital. The difference I see is that younger generations have a different set of values. So when I talk to co-founders now, their values are different from those 10 years ago, and sometimes very different. So the simple things. Sometimes you talk to them, obviously the discussion is going to go down the way of eventually getting into a negotiation, and the way younger generations see that is like more opportunistic than people one decade ago. 1 decade ago, people were more conscious of the investor and what was going to be the return of the capital to the investor. Today, that's even a challenge. People think that investors have essentially money that they can deploy, and it's going to be lost. And there is no actual commitment to return the capital to the investor. It's risk. So that was different 10 years ago. That's kind of one example.
Yeah, it's hard to compare 2009 to now because 2009 it was just such a tough time period, right? It's a very good time to be raising money. I think I was supposed to have a meeting tonight at 9 o'clock, go to Redwood City, present a term sheet, and I got a call this afternoon. It's like, okay, don't bother. They've signed another term sheet. They had like 3 different offers, right? So this is happening. And also, you know, the SoftBank Vision Fund is sort of a game changer. And, you know, you think, well, that's kind of a crazy amount of money, $100 billion fund. Now they're talking about raising another $200 billion after that. And you think, okay, well, we're living in a bubble, that kind of thing. But, you know, I think things like that is actually an indication of how technology is really having such a huge impact in the world. You know, you look at the top 5 companies in tech, they're the top 5 out of the 6 most valuable companies in the world, almost 10% of the entire stock market value. And so tech is having a gigantic impact, and I'm actually happy to see the Vision Fund and things like that happening because as a small entrepreneur, right, I mean, you know, getting millions of dollars of funding to start seems like a lot of money, but if you're able to raise that and achieve some level of success, then getting the next $10 million, $50 million, $100 million is now possible, whereas before it was like, that was kind of crazy, right? Now you could actually, you know, one of our portfolio companies raised $1 billion from one investor in a single round. I mean, I never thought we would see that, but now Vision Fund is around, they're talking about making a $3 billion investment, $5 billion investment, one investor in a single round. And if you're an entrepreneur and you have a company that really is achieving success, having an impact, you can now get access to this level of capital where you could actually compete against a Facebook or Google or Amazon. Whereas in the past, I mean, how can you compete against these gigantic companies? It's kind of crazy, right? But you know, startups can actually get access to capital in a way that was just, I couldn't even imagine when I got started in the venture business. Back when I got started in 1990, I was working for this firm called Trinity Ventures. We had 30 million under management. The entire venture capital industry had raised about $1 billion in 1991. That was a recession year. The entire industry. This sort of world has totally changed. Yeah.
Okay, thank you.
Thank you. One last comment. Thank you for telling everybody the difference between deep learning and then that it's a part of machine learning, which is a part of AI. That's really refreshing to hear. Thank you.
Hello. What's the investment scene for AI in healthcare, specifically the mental health and behavioral health related issues? And is any of you are interested in that space? Just would like to get your feedback.
AI and healthcare is the question, specifically mental health.
I don't know, but I hope something comes about it. You know, I think psychologists and psychiatrists are like one of these professions. They're going to be very well protected against AI. I mean, more and more people are, you know, like relying on these professionals. But within healthcare, you know, we have a company called Synteca Bio, which had an algorithmic approach of analyzing all this DNA data to spot rare diseases. And then they started to run these experiments with using deep learning instead of their algorithms. And like you said, like if you have the algorithms and if it works, that's better than deep learning. But then you run it side by side, and then they realized that the deep learning results were better. And so they dropped their algorithmic approach. This is similar to this is where the Google story came out, because they sort of told me that story when they made that decision. So these kinds of things are happening in fields that we didn't expect. I mean, we normally don't even invest in these kinds of, in healthcare, we're a software investor, but we made an exception in that case because these guys were software developers applying it in medicine. And we did not invest in an AI company, but now they're using, like, you know, they made that change just a few months ago. And since making that change, again, the results are very promising and is leading to the next round of funding. But mental health is a trickier area than spotting, doing a human genome analysis, and that's, I hope we make more progress. But I haven't seen any startups in that sector. I mean, the easiest cure is like popping all these pills, right? I mean, we're the most over-medicated society.
Now, there are many conversation agents, and there's quite a few already in place, just addressing the therapy point of view. So I was just asking if there is a specific interest from your side.
Yeah, I'd love to hear about it, because I haven't been pitched, but yeah, that's an interesting area.
Okay, thank you.
Hi. From your experience right now, what are some of the verticals that you see AI most applicable in the next 1 to 2 year horizon? Now, you already mentioned ag tech. Of course, there's business analysis is other area that we all know about. But what are some of the areas that you guys are getting excited about and hoping to see a lot of people coming forward and asking for money in the next year or two?
I think there's a lot of stuff going on in predictive maintenance for machines. So larger companies like GE and even those players, basically taking all the sensor data from the edge, using all of the data sets to kind of combine that with understanding what is the health of the machine and preventing breakdowns, because some of these machines, if they break down for an hour, it has a huge impact on productivity in the entire supply chain, or entire kind of like that thing gets disrupted. So the whole idea is how can you prevent that by either predicting when the breakdown is going to happen, and then take corrective action before the machine breaks down.
Yeah, I'm starting to look at smart robotics, which are an interesting area, part of sort of Industry 4.0. I was going to say predictive maintenance. You stole it. but yeah, I think it's quite exciting to see manufacturing moving into more dynamic environments where robots are able to perform higher level functions aside from just the very repetitive movements that are being programmed, and now you can just even show robots what to do. There's a whole subfield of human demonstrations where a human performs the task, a camera watches, and a robotic arm just repeats it at a conceptual level, right? So the conceptual level would be grab a bag of chips and put it into a box, and every a bag of chips could be at a different location, and it's really understanding the task at a conceptual level.
We've had a sort of an investment thesis around a particular area called what we call DIFM. One of my partners wrote a blog post about this a few years ago. DIFM stands for Do It For Me. And it was a thesis around combining humans and technology together to deliver the full solution. So technology by itself doesn't do it. Humans by themselves is not scalable. And so that white hat security was an example. Uber is an example, of course. And so we've made a whole bunch of investments in what we call the DIFM thesis. And now what we're doing is like looking at that again, and every single one of our DIFM companies where humans are involved and technology, algorithms, big data is involved, how do we then apply machine learning to that realm to then accelerate and make that process more efficient and just radically better, right? So we're sort of looking at that entire investment thesis, again with the AI angle on top.
We talked about it a little bit earlier on, and I think this computing in the edge or applying machine learning or AI in the edge, IoT combined with IoT devices, robotics, as you mentioned, is going to be a big theme moving forward. And also the big players are releasing now chips and technology or components to be used in those devices, which already incorporate all the necessary elements to compute and run machine learning really in the edge. And that's going to change really the game moving forward in one way or another, because we'll enable all those applications to be more smarter, more efficient. And that, in my mind, probably is going to be a big theme in the next couple of years.
So Rob, we're at 8:30. Do you want to go ahead and take the rest of these questions? Okay, well, thanks very much. Next question.
Hi, yes, my question is about actually presenting to you. And so while I'm trying to prepare my amazing pitch and get you really excited, I'm wondering, how do I balance this Are you going to be more excited about the problem that I'm solving, the solution, like the high-level solution that I'm giving you, or the technical details of how the solution works, and how do I balance that? Or is there a way?
So I'm going to be excited about the problem that you're solving, right? So, and then the economics of the value extraction, right? So if you can show me that there is a problem that has a sort of, that has a market over $1 billion, I'm going to get very excited about that. And I, the very last thing will probably be, after I asked you about your team and other aspects, I will probably then start exploring the technology. But for me, the technology is the last piece.
Yeah, for me, what I look for, first of all, when you pitch an investor, the goal is not to try to get the money. The goal is to sort of get them engaged and interested and curious, and then then you get to engage and you get to learn about each other and about the problem and to continue the dialogue, basically. And so when an entrepreneur comes in and we're going to be the Uber of this or the Airbnb of that, it's like, oh, geez, that's not as interesting. If they come in with some kind of problem that's I hadn't heard of before, it's like, okay, well, that's kind of interesting. Or even better is if they come in with an idea, I'll give you this specific example, where I think it's kind of a stupid idea, but then they have this data or sort of like, hey, look, this is what's happening with my customer base. It's like, oh, this is really interesting. So it's like Roblox is one of these investments we made like 9 years ago. It's like, oh, that's a stupid idea. It's like they talked about kids playing Lego online, 3D worlds they're going to create and all this stuff. This is all before Minecraft took off. And it's like, well, that's kind of a dumb idea. It's like yeah, kids love to play Legos. I have little kids. But why would they want to play it online? So, I dismissed the idea, of course. But then he came with the data. It's like, well, but look what's happening. It was a tiny company. They were doing like maybe $50,000 a month in revenue. But it was like this usage pattern was growing at 7% every week. So 7% is not that much, but if it's compounded growth every week, and they had this data of engagement 52 weeks in a row, 7% growth. So it's like, it didn't explode, but 7% compounded is 33x in a year. It's like, oh, this is kind of exponential. Something's going on, right? Got us curious, and then we the more we learned about it, and we found 200 videos on YouTube. It's like, there's not that many videos, but kids were uploading their videos of the worlds they were creating because they wanted to share it and they wanted to show it off. It's like, hey, there's real passion in this community. They're talking about it. There's 200 videos. Now I think there are like 50 million videos on YouTube of Roblox videos. You could go Google it, and I think Minecraft has probably over 100 million videos. So it's like, okay, now it's proven. But 200 was enough to show us hey, something's interesting about this. Something's going on, and made us curious and learn more and more about, and then found out more about the entrepreneur and his backstory and why he was passionate about this. He had 4 kids. He wanted to do something that was really educational, good for the kids, and all of those things you find out after that first meeting.
Thank you.
Thanks, first off, for all your insights. A really good panel. I have a 2-part question. There's a famous S-curve for technology where it goes from hype to disillusionment to enlightenment. Where do you see AI fits on that curve? And then the second part is in terms of the universe of opportunities where you invest, including blockchain or IoT, how do you compare AI in terms of opportunity and the size and scale of the opportunity versus those other opportunities?
Great question.
Yeah, for the first one, and I'll send you the link later on. We always follow the Gartner hype cycle. It's like a reference in the corporate world. So we receive the materials every year. This year, in particular, 2017, machine learning is at the top of the hype. And then the Gartner curve will give you, to your point, there is a valley after that, a valley of unfulfilled expectations, and then there is a recovery in the curve, and then the technology will be there. Probably commoditized or massively adopted. And they are giving us between 2 to 3 years in terms of estimation of massive adoption of machine learning. Machine learning is a proxy for AI in a way, so you can think of AI coming as a second wave after machine learning is readily available for everyone. And I have the slide somewhere, so I'll make sure that I can get it to you if you are interested.
To me, it feels like machine learning was sort of highly sort of invested in sort of almost blindly, and then now investors are starting to smarten up about how to invest into AI. But then the entrepreneurs are also smarter about applying AI to bigger and bigger problems, and our capabilities are growing exponentially. So all of it is balancing out. I think that the numbers are in 2016 almost let's see, $4.9 billion went into AI companies, and it's the investment is accelerating. So I think the 2017 number is going to be probably over 6 billion. So so while there's supposed to be some trough of disillusionment, I'm not entirely convinced that the disillusionment is going to be very, very much of a disillusionment. I think a lot of companies are going to go away that raised on at the top of the hype just for the sake of using machine learning, and then there's no value there. But I think the value of machine learning is here to stay.
Let's give it up for our panel. Let's hear it for our great moderator, Roger Royce. Let's hear it for the College of San Mateo, our sponsors, our video team, and our event team. Let's hear it for you, our audience.
Hey.
Let's hear it for Rob.
Last but not least, let's hear it for me.
Finally for Rob.
So the video will be available on our YouTube channel in a few weeks, youtube.com/idea-to-IPO. Our panel will stick around. You can talk to them for a few minutes, take some pizza home. Thanks for coming, and we'll see you next time.